Let's begin this video by doing a little multiplication. So let's start with x plus 5 times x minus 5. So we can do this a couple of different ways. Let's do... So let's distribute the terms of the first binomial through the second binomial. So that would mean that we're going to take this x and distribute it through, and then we take the 5 and distribute it through. So let's see what we get. So x times x gives us x squared. X times negative 5 gives us negative 5x. Positive 5 times x, positive 5x, and positive 5 times negative 5 is negative 25. If we simplify by combining our like terms, the negative 5x and the positive 5x will add to 0. So that gives us x squared minus 25. Let's try another one. 3x minus 4 times 3x plus 4. Same process. We're going to distribute 3x in the first set of parentheses through the second set of parentheses, and then we'll distribute the negative 4 through the second set of parentheses. So multiplying 3x times 3x gives us 9x squared. Multiplying 3x times 4, that's this line, that gives us a positive 12x. Multiplying negative 4 times 3x, that's this little curve, that gives us a negative 12x. And multiplying negative 4 times positive 4, this curve, makes negative 16. Combining like terms, same thing is going to happen here that happened in the first problem. The middle terms, the positive 12x and the negative 12x, add to 0. So that gives us, for final simplified version of this product, 9x squared minus 16. So starting to notice a pattern here, I hope. Whenever we multiply the sum and the difference of the same two terms, we end up with an expression where two of the terms will add to 0 and thereby cancel each other out. So this is called the difference of two squares. Notice here that in the first problem we have the square of x minus the square of 5. In the second problem, our result is the square of 3x, because if we 3x times 3x, or square 3x, we get 9x squared, minus the square of 4. So this type of expression that we're ending up with here, the 9x squared minus 16 and the x squared minus 25, is called the difference of two squares. I've heard some students refer to it as dots, the difference of two squares. So we can use this pattern that we've discovered here in order to factor other expressions that fit the difference of two squares pattern. So let's give that a try. So let's begin with 9x squared minus 64. So what I want you to notice is we do have perfect squares in both of these terms. 9x squared is 3x times 3x, or 3x squared. 64 is also a perfect square. 64 is 8 squared. So using the pattern that we just discovered, we will have 3x plus 8 times 3x minus 8 for the result from factoring. Now, one thing about factoring, a lot of students do find factoring to be a little difficult. One thing, though, about factoring is you can always check your answer. So you can always check by multiplying these two binomials together, and after you combine your like terms, you should end up with the expression that we started with. Okay? So let's try another one. Let's get just a little bit scarier looking. How about I do x squared minus the quantity 3a plus b squared. Okay, so this looks much scarier than it is, because this is a square minus another square. So it's the difference of two squares. So that means that when we factor, we'll have that first square root, the square root of x squared is x, plus 3a plus b. Now I'm going to keep the parentheses around that just for emphasis. And then our second set of parentheses, the terms, the x and the 3a plus b, will be the same, but it will be subtraction. And again, keeping the parentheses around that is a good idea, because now I can simplify by removing these parentheses and these parentheses. So when I do that, since we're adding in front of this set of parentheses, we just remove the parentheses and nothing else happens. This one, that subtraction symbol right here. Okay, not sure what happened there. We'll get rid of that lovely squiggle that I accidentally made. So going back, that will give us x plus 3a plus b, and then distributing the subtraction or the minus sign through the parentheses, this set of parentheses will turn into x minus 3a minus b. So that is the correct factorization for that particular problem. Let's try one more. So let's begin with 8x plus 5y, and that's squared, minus 3x plus 2y, and that is squared. Whoops. Okay, so this is again the difference of two squares. Now, I have seen students multiply this out. In other words, square the first set of parentheses, square the second set of parentheses, combine like terms, and then attempt to factor the result. Easier way to go. Here's what you do instead to make it a little less work. So since this is a square minus another square, we can use the difference of two squares to factor, in which case we'll get 8x plus 5y plus 3x plus 2y times, same thing but with a minus sign in between, and 8x plus 5y minus 3x plus 2y. So now I'm going to simplify. So inside this big bunch of brackets here, I've got an 8x plus a 3x, so that's going to make 11x. I have 5y plus 2y, so that makes 7y. And inside the second set of brackets, now we might take an extra step on this one just because of the minus here that needs to be distributed. So let's take one extra step to do this one. We have 8x plus 5y minus 3x minus 2y. So let's keep going. 11x plus 7y. And when I combine like terms, I will have 8x minus 3x makes 5x. Those are like terms. 5y minus 2y makes 3y. And that is my factored form in its simplest way it can be written. So let's do a little experiment here and see what the other option would be on factoring this original expression, simplifying it as far down as you can and then factoring. So I'm going to go to another page and I'm going to redo this problem in a different way. So starting a new page, eight x plus 5y quantity squared minus 3x plus 2y quantity squared. So another way to simplify this would be to first square out the parentheses. So this would be 8x plus 5y times 8x plus 5y minus 3x plus 2y times 3x plus 2y. So now we're going to use the FOIL process, if you want to think of it that way, or distribute like we did earlier, 8x times the 8x and the 5y in the other set of parentheses. So this 8x times 8x is 8x. 8 times 8 is 64, and then x times x is x squared. 8x times 5y is 40xy. 5y times 8x is also 40xy. And 5y times 5y is 25y squared. Now I'm going to come down to the next line, and I'm going to put my minus sign and then multiply 3x plus 2y times 3x plus 2y. So that will be 9x squared plus 6xy plus another 6xy plus 4y squared. Now we need to subtract. So notice the subtraction here in front of the big set of brackets. So because I'm running out of space, I'm going to skip a step here. We've got 64x squared minus 9x squared. And 64 minus 9 is going to make 55x squared. Then we have 40 plus 40, that's 80xy, minus 12xy, 6 plus 6. So 80 minus 12, and that's 68xy. And then 25y squared minus 4y squared is 21y squared. Now, since we have not factored anything like this yet, and that's going to be my next type of factoring after I finish the cubes, I think I will leave it up to you to verify that what we got on the previous page will actually multiply together to give us this result. So we'll talk about factoring things like this, although these numbers are a little messier than what you're likely to see, just because they're kind of big. But I'll leave it up to you to verify that this actually is equal to what we got by doing it the other way. And I think you'll agree that the first way that I factored this was easier. So we would come down to the next step, and 11x times 5x is one way to break up 55x squared, and 3y times 7y is one way to break up 21y squared. So if we do 3y here and 7y here, we can check, and we just have to check the outside and the inside pieces. This would be 35xy, this would be 33xy. Where'd my y go? And if we add 35 and 33, we do indeed get 68, and everything is pluses here. So you can verify that if you like, but it really does work either way. So hope that helps. I will move on to the next video now.